Hello, this is FRJ Tracing, and this is going to be a really quick video on is Unity a bad game engine? And if you may not know, is that Robocraft has always been built on Unity, and it's been built on Unity 4 from about 2014 to 2015, and then when the engine updated to Unity 5, they updated everything with it. Now, I've seen a lot of the community. I've actually also had some conversation with people over voice chat about if Unity is a bad engine. And we also have some community members that develop in Unity. And if you're not a developer in any way or you haven't played around yourself, you can't really solve that. You can't answer that question precisely because people will blame the game engine for a variety of different things, but the the end thing is that, if you put crap in, you get crap out. But also some of these engines do other things better than others. So you might have seen some of this featured in my Power and Force video, but now I'm going to dive into what makes this special and how this compares to Robocraft's way of attacking the same kind of problem. So a big thing I hear is that the Robocraft gameplay experience is not fun because Unity is a bad game engine. And I'm just going to have to stop anyone that has to say that there. And I'd like to show them this completely modular wheel system that I made that uses all rigid bodies and physics in real time. And then I would like to see what their kind of response on this is. So if I go to play this, I can define this as the active player, and you can see I've created my own grip model. And then also another special thing is that this has dynamic suspension, so you can see the suspension change in real time and become a little more bouncy. Let's see if I can get it in camera. Here you go. You can see a lot more weight transfer there. I can also turn down the damping. Again, it makes it more kind of bouncy and more reacting to force changes. And then another thing this will do is I can actually change rule steering in real time. As you can see here, these are all the same game asset, but I've coded this in such a way that they are all like self-aware of each other. Now you might have noticed that just passed through this one, but that's because this isn't an active player and I turned off the colliders on it. So don't worry, don't get too hung up on that. Alright, so to expand on how special these wheels are, I can actually take some more of these. Yeah, let's take these two. And I can just copy them here and keep going and going and going. And while we're at it, let's just copy all the ones that we, and why not copy some more over. So now you'll see I have over 30 of these assets. I didn't change anything. I'm going to go right into play mode. Mind you, I'm also recording right now. And let's go into the active suspension. So as you can see, it just works. No weird speed boosts or anything odd. This uses my unified power and force system. So it has a set top speed and the forces value scale with how many you put on here. And they also scale with mass, so another thing to consider. And then I can set these all to rear steer. And hopefully I can get this in screen again. There you go. So to also showcase this compared to, say, how Robocraft handles wheels, with this whole grip model I made a what's called a wheel energy, or I'm sorry, your equivalent energy that is occurring there, which is a byproduct of speed and the amount of friction that it needs to occur, which is, again, a byproduct of the acting mass on that wheel. So I'm going to call it a tire energy model. And I can actually change the grip or the threshold here, and then the tip grip, which this is something that's, if it starts to tip over at a certain angle, it will start to lose that equivalent tire energy. So I'm going to turn down this grip coefficient, and you can see that again without configuring all these all over again. This is one script acting 30 something times over. As you can see, it's very slippy. I can barely steer. If I put in rear steering, it's very slippy and drifty, but it still, works like a normal tire, and it has, it treats itself like a normal tire. There's nothing too special going on there, except for the fact that I have 30 wheels trying to hit other things. So this is just an example of how you approach physics-based movement, and these use other things like joints. Let's go into one of these assets. These actually have real configurable joints and other things and running their own scripts, and they're self-aware because they can reference a other object. Like if this was the center of mass object, it actually references this to see where everything else is compared to itself. So again, it's a smart scripted part, and it's completely modular, and it doesn't matter where it is. In theory, you could quote unquote place this on a cube and it'll just work. Now let's go over to the Robocraft experiments. I am really glad that Mark is doing something about this, and what's something you need to understand is that I kind of have seen this coming. I think Mark is going through some kind of like nostalgic midlife crisis, which is the way I can put, because you got to understand is that Mark is running Free Jam, and this is like his passion. He loves like physics and stuff like this. But when he got really busy in the earlier years of Robocraft, he handed it to other game designers. And over the years, it got turned into this COM assisted, like what that means, center of mass assisted way of movement, meaning that the physics of an object are actually modifying an object's transform. So, for example, if I were to look at this game object as a whole, and I were not to consider all the other physics objects, you can code this to move around based on its transform. So you could tell the transform to move up to this position if something happens, or you can tell the transform to rotate, or do any of these things. And as you can see in the bottom, the camera updates, and that's what the game would see. So you can hard code movement to emulate physics, but then that's running independent of the physics engine. What I have here is each one of these things are actually using real forces, real collisions, and real calculated forces that are acting on different parts of the entire asset, as well as built-in Unity features such as springs and joints. So this is something that is a completely different method, which is what the experiments is using. If you look at some of these, you'll notice the seconds he goes into runtime, this asset is just a rotator joint, some kind of motor, and then you have two game objects here, two transforms, and then another mounting point. And these are just a collection of rigid bodies that are fixed together. So there's nothing special going on here that Unity can't handle. And if you go down here, there's another video where they presented this GIF. If you say GIF, I'm just going to say you're wrong. I'm going to call it GIF. Other people call it GIF. Get over it. So anyway, you can see this where you have a collider and then another physical object. And it's just another presentation of how a game that has assets that are set up with physics objects and Unity can give you that realism that you are looking for. Now, this in context of a voxel game, which is what Robocraft is, where each one of these parts have to be placed in real time or in a build mode, you have to understand some principles of game development and coding and the limitations of your knowledge based on what can happen. Because you have to think of two situations where you load into the new frame. You start the first frame of the scene, and then you code it to set up all these things. And then real time, every frame update, you have to script something to happen. So, for example, all these wheels technically are displayed in what would be the state when they're instantiated. So when one of these objects, if I go into my project and bring in this prefab would be instantiated into the game. And it has, these all have their own settings that are either defined in the script, and they'll run this set of scripts on the first frame, or they'll have things attached to them that are game objects, and also these game objects will have components such as rigid bodies and joints already set up. So when this loads in, it instantiates every instance of these game objects, and it runs this code. So then you can see in my code here, I'm defining, I'm calling this object this, and I'm saying, grab the components from this object. And then I'm also saying that, it'll have rigid bodies, and then I calculate things that are in reference to other things in the first frame. And anyway, this first frame kind of like sets the foundation. And then every update, you have to tell it to do something. So then I'm referencing all these things that I defined in real time. So something that's really bad to do is to instantiate or create components such as a rigid body or joints every frame update. That's really bad to do, and I actually, based on how I have like a sound system here that's set that like it will amplify the noise from like my processor, and like I don't know how to explain it, but or disk usage, and the disk usage gets amplified through like this solid state speaker system I have. It's really weird occurrence, and it only happens on one of them. Anyway, I noticed when there's a lot of write speeds and reads happening in one frame on any game, I can tell based on the pitch that it runs at. And to put it in perspective, I have that very sound system on right now, and when I run the game, I cannot hear that at all. When I used to, I did accidentally, while I was learning, code some of these joints to get put into a matrix every frame, and then it was filling a list in a matrix of things every frame multiplied by how many of those assets were running. So then, like, if I had 31 of these and I had 31 lists filled of 31 objects, then you get a like a square of that, which is in the hundreds. It's like almost 900 something. So you have that going on. And when I play Robocraft, I can hear that same pitch thing going on. And that's a byproduct of them referencing things in a way that are inefficient, and it's running a lot of code. Even in the garage, it's running a lot of frame update things that are really intensive. And for the same processing power, I can do what I just showed you here relatively without that much load on my CPU, and that's 30 let's say 32 game assets here that are loading and calculating physics in real time. So that's the first thing. That's the first challenge of a voxel game, is that whole concept of instantiating something and it working after you instantiate it. Now, the easy way out of this, which I believe Robocraft uses a lot of, is COM-assisted or hard-scripted movement. So to kind of simplify what that means is like this thing right here is just like a random 3D model, right? But I can move it around and do stuff here in the editor. But as you can see here, watch the position. That has a position that you can define in real time, and you can tell, hey, every frame update move position or rotation. Extending on that, having game objects nested in a game object allows you to do things where if I were to copy and paste this, as well as move it over, and then move this game object here, I would actually be moving both. And that's called parenting and making childs of a game object. So once you understand these very simplistic ways of approaching how things position in the game, you can take on things like animations and making things present themselves so that they look realistic, but in reality they're not calculating any kind of physics other than collisions. So to extend on this further, there's a thing called kinematic rigid bodies. So if I wanted this rigid body right here to let's go to gizmos or maps. But anyway, the point is that I can make this rigid body, which is like a physics object. Like if you think of something with mass and inertia and stuff, this is what does that. So you'll see when this starts up, it'll do its thing and everything will work. But then if I mark this as kinematic, then you'll see here that it no longer works inside the physics engine, but the parts that are attached to it are. So if I were to make this active, you'll see here that I can, both of these are now active. Let me uncheck that one. You can see that it's trying to do something, but because it's floating in the air, these objects can interact in the physics engine, but this one cannot. So let's make this one active, and let's try to run into that a little bit. And you should see something happen. Oh no, I layered these so that they can't hit each other. So that's a way that I layered colliders. But as you can see here, these do have colliders on them, but they can't touch what's here, unfortunately. Oh yeah, they can. There he is. You see it hit? So that collider and that collision still works, but the way that you would code this to move is you can literally tell this to move in real time. And like, so the script would be doing this, and mind you, the game is running. Like, this is doing fixed updates and updating each frame. But in reality, this can actually act like a physical object. So that's what happens when you have a kinematic body. But if I were to watch what happens when I make this non-kinematic. Now it acts like a normal thing. So this draws the line in between the two scripting methodologies. So the problem with normal Robocraft is that it's coded with the idea that you move the transforms and that the forces do result in inertias and rotation and stuff like that, but you can mix and match these two processes to fit like a really strict way of movement. So for example, wings, a lot of the movement actually back in 2015 and before used no comm assist. And the first time we started seeing this is when mechs were implemented. They inherently use this method of movement because coding a physics system to make the mech legs work would be really, really difficult. So they follow a set of animations and inverse kinematics to move around. But the physics of them, like the actual, like they don't have a force that says, hey leg, hold me up and balance me, because I can already tell you now that coding a control system to support legs in real time, it's very intensive and would in itself require a systems and controls degree to even go about programming that controller. So instead of doing that, you can say, hey, play this animation and orient this object in this way. Then when that object is not active, treat the object like a ragdoll, or it'll turn on the kinematics. So like, for example, when a mech falls over, it'll switch over to like inverse, or it'll turn this it'll turn that rigid body into kinematic, and then you can tell it to do something, or you can tell it the other way around and have it use gravity and stuff. So Robocraft overall mixes and matches those two systems, and as they've moved away from that physics movement, they've created this game that's honestly getting more and more boring to play, and doesn't have that not realism, but it doesn't have that like that return on building that you used to have. Like when you built a certain way and you like oriented things a certain way, they would react that similar way. So now that we have that, going back to the experiments, now they're working on this, and oh my goodness. Anyone that's been around since 2014 knows when they see this, you just have to roll your eyes, because it's like the thing that they've always asked for, and everyone's like, oh my god, this is like the best thing in the world. And like, this is basically the OG meme of Robocraft, because when this came out, this was like the dream everyone had, that we couldn't have it. Again, the reason why is Unity has had all these tools in there, but the method at which they coded the game is not conducive to how this would work. As we continue further, you can see more of these rotating parts and using colliders and physics objects. So overall, Robocraft is this Robocraft experience is really nice, and the whole Unity is a bad engine. I kind of wanted to remove that perception and have everyone understand that it's not the engine's fault. it's the coder's fault. And if you put crap in, you get crap out. So I hope you learned something from this and can have a good night. Well, if you like what you see, please drop me a like and subscribe and hit the notification bell. And I hope I can provide some more Robocraft related content that you can enjoy, and hopefully we can turn this around.